we saw the two-dimensional Cartesian coordinate system. Now let us get into the circular coordinate system. This is given with respect to the Cartesian coordinate system because we need to have the conversion procedure. This is x-axis, this is y-axis in Cartesian coordinate system. When we wanted to determine the coordinates of this point in Cartesian coordinate system, we drew a line parallel to y-axis, passing through the point of intersection, point, and then we see the point where this line intersects x-axis, x0. Then we drew one more line passing through the point and parallel to y-axis. If this point is intersecting y at y0, in fact, they can be positive or negative, I'm not worried about it. I'm showing it in the first quadrant, but it need not be. Because of which the coordinates of the point are x0, y0. There, we represented every point mathematically as the point of intersection of two mutually perpendicular straight lines. Now, in this coordinate system, the circular coordinate system, taking this origin as a center, a circle is drawn through the point of interest. This is the circle of radius r on which the point is lying, one line. Circle of radius, let us say rho. Now, given x0, y0 as the point, what is rho? Root of x square plus y, x0 square plus y0 squared. It is rho naught. Okay? It lies on the circle of radius rho naught, having the center at the origin of the Cartesian coordinate system. When you say a point lies on the circle of radius rho naught, it can be at any place which is one of the infinitely many points on the line. To represent this, from the origin, a line only extending forwards to the point of interest is drawn. This makes an angle phi with positive x-axis in, very important, anti-clockwise direction. This is phi naught. Actually, now the point is the point of intersection of two lines in which one is the circle of radius rho naught having the center at the origin of Cartesian coordinate system, and another is the line passing through the point of interest starting from origin, not extending backwards. The same point in this coordinate system will have the coordinates rho naught, phi naught. Check it once. In this coordinate system, every point is represented as the point of intersection of the circle having the center at origin of radius rho and a radial line starting from origin only in one direction. And making an angle phi with positive x-axis. Reference is Cartesian coordinate system. We always say this. Angle phi in anti-clockwise direction. Check it. This is the transform formula. Z r at an angle theta, r e power j theta, r at an angle phi. Phi measured from positive real axis, x-axis is positive real axis. In anti-clockwise direction, omega. In this, 0 less than or equal to rho less than or equal to infinity. X takes the values from minus infinity to plus infinity. Y takes the values from minus infinity to plus infinity. Rho takes the values from 0 to infinity because radius cannot be negative. And 0 less than or equal to phi less than or equal to 2 pi. Positive 2 pi is always in the anti-clockwise direction. Check it. Every point is represented as the point of intersection of number 1, circle of radius, right? Circle having the center at origin of radius rho and a radial line starting from origin and making an angle phi with the positive x-axis. If somebody gives you a point in xy plane, draw a circle through it, measure the radius, that is one coordinate. Draw a radial line passing through that, measure the angle, that is the other coordinate. Rho naught, phi naught is the coordinate. In which, careful, in x naught, y naught, both will have the same units, meters, centimeters, whatever it is. But in this, one is in meters or centimeters, other is angle unit, right? Normally, meter and radius is what is the normal thing for when we are following something called as SI system of units. Radian. We can talk about it as degrees also. Listen carefully now. In Cartesian coordinate system, we could define and we derived the formula also. to straight away determine the distance between two points x0, y0 and x1, y1, or x1, y1 and x2, y2. Actually, this is because later on we could define the vector from any point to any other point. In the standard form, means as the linear combination of vector sum of the scaled standard unit vectors ax and ay, the directions of which are fixed irrespective of the point at which we define ax and ay. In this coordinate system, we can determine, but we don't speak about the general distance between 2 points. Because anyway, one coordinate is not the distance. One coordinate is the distance, has a distance unit. Listen, if somebody gives me the circular coordinates of 2 points as ρ0, φ0 and ρ1, φ1, I will in general calculate the distance by taking the coordinates into Cartesian coordinates and define a distance. First thing that I want to talk about now is how to calculate the Cartesian coordinates of a point given its circular coordinates or vice versa. Check it now. Be careful. It's important for us to know this. I think I told about it while talking about the polar and rectangular forms of phasors. I will now again talk about it. We know this. The discussion is this. Given ρ0, φ0, what is x0? Okay, ρ0, φ0 is r at an angle theta. What is the real part? X-axis is the real, x coordinate is the real part of it. R at an angle theta, ρ0 at an angle φ0. What is x0? ρ0 cos φ0. Listen carefully. Cos theta from 0 to 90 is positive, 90 to 270 it is negative. 270 to 360 it is positive again. Understood? X0 is ρ0 cos φ0. What is y0? ρ0 sin φ0. Given ρ0 and φ0, determining the x and y coordinates of these points is very easy and straightforward. Again, r at an angle theta is r e power j theta is r cos theta plus j r sin theta. R cos theta is the real part, x component. R sin theta is the imaginary part. Imaginary part is y component. Both can be positive or negative. Now, given x naught comma y naught, hope you remember this. X naught rectangular coordinates of the point are given. I want to calculate the distance of the point rho naught. What is rho naught? No doubt about it, because it is the distance of the point from origin. Rho naught is equal to square root of x naught square plus y naught squared. Even the first two equations are giving the same information, that x naught square plus y naught squared is rho naught squared cos squared phi naught plus rho naught squared sin squared phi naught. Under root, if I take, rho naught will come, because sin squared phi naught plus cos squared phi naught is equal to 1. What is phi naught? The equations above are misleading us. We normally get tempted to say ratio, take ratio. Tan phi naught is y naught by x naught. Phi naught is tan inverse of y naught by x naught. Is not true, we know that. Definitely, if x naught, y naught is there in the first quadrant, that's what I was talking about. Definitely x naught and y naught are positive, first quadrant. Check it. This is the point. This is x naught, this is y naught. This y naught is tan inverse of y naught by x naught, if x naught is positive. If it is there in the second quadrant, this is x naught but minus, this is y naught. The angle is always to be measured from positive real axis. X naught is negative, but mod x naught will give me this angle. Tan inverse of y naught by mod x naught will give me this angle, but I want to know the angle from positive x-axis. So talk about it. This is tan inverse of y naught by x naught. No, I'll not talk about it now. Okay, yeah. This is tan inverse of y naught by x naught. In this quadrant, what is the formula? In the second quadrant, this total phi naught is what? Pi plus tan inverse of y naught by x naught. Check it carefully. If y naught is positive, x naught is negative, when I substitute it, pi minus tan inverse of magnitudes will come. Correct. This angle from positive x-axis is tan inverse of y naught by mod x naught, pi minus, correct? Pi minus tan inverse of y naught by mod x naught. I will not normally look at the sign in this, right? Now, if I do it as pi plus, it works for both third and fourth quadrants, in which y naught is negative, x naught is negative. This angle is what actually 180 plus tan inverse of y naught by x naught, substituting the values of y naught and x naught with their signs. Negative by negative is positive, because of which it will be more. If it is there in the fourth quadrant, x naught is positive, y naught is negative. Tan inverse of y naught by x naught is negative. I'll say minus angle. Otherwise, 2 pi plus tan inverse of y naught by x naught I can put. So it is open to questions. 2 pi plus tan inverse of y naught by x naught if x naught is positive. Pi plus tan inverse of y naught by x naught if x naught is negative is the formula. Once x naught is negative, formula is pi plus tan inverse of y naught. Y naught and x naught, they can be both positive, both negative. You have to look at the sign of x naught, select one of the formulae, and then calculate the angle. Very, very important for us to know the relation between a plus jb and r at an angle theta also. Same it is. Square root of a square plus b square. Theta is, I told you, 2 pi plus tan inverse of b by a. AB can be positive or negative. If A is positive, formula is 2 pi plus tan inverse of B by A. If A is negative, irrespective of B is positive or negative, pi plus tan inverse of B by A. The same thing we followed actually. Check it. Once I get the x and y coordinates of the points, we can calculate the distance between those 2 points using the formula in Cartesian coordinates. We can actually think about, listen carefully. We can actually think about the distance between 2 points in the circular coordinates also directly if you are comfortable with direction cosines. We know that if there is R1 and R2 theta, what is this side? What is this side? Cosine rule. What is that side? Select set. Root of
R1 square plus R2 square minus 2R1 R2 cos theta.
Minus for this, plus for parallelogram law of vectors. This is the cosine rule. This is the cosine rule. Now, if somebody gives us R1 at an angle theta 1 and R2 at an angle theta 2, it is possible for us to R1 theta 1, R2 theta 2, or R1 phi 1, R2 phi 2. The difference is phi 1 minus phi 2 or phi 2 minus phi 1 magnitude. If you know, we can use this to calculate the distance between 2 points in circular coordinates if I want only the distance. Cos theta is what? Cos of phi 1 difference of phi 2. Whether it is, if it is cos, whether it is phi 1 minus phi 2 or phi 2 minus phi 1, it makes no difference for us. Okay. Good. Next. Minimum angle, in fact, we have to take between those two lines. I should not take this angle. This angle can be at the most 180 degrees. It cannot, right? I will not take anything more than that, because I would have taken the angle which is included angle between them. The included angle between two angles can only be 180 degrees at the most. Correct? Please check it once. If it is required, r cos theta, r cos phi, r sin phi, or x naught and y naught, we use it. People use this heavily when they go to polar coordinates, right?